One special type of series that we're interested in is what is called a geometric series. And a geometric series is where you start with the number, and to get from one number to the next number, you're multiplying by the same number every single time. So this is an example of a geometric series right here, 1 plus 1/2 plus 1/4 plus 1/8. So notice to get from the previous number to the next number, you're multiplying by 1/2 every single time. That number that you multiply by every single time is called your common ratio, which in this case would be 1/2. So a series that looks like this is called a geometric series. So in sigma notation, we could write it like this. So if I start at n equals 0, so notice your first term would be a, because r to the 0 is 1, so there's your first term. And then as your counter here goes up by 1, you're multiplying by r. And then the next time you're multiplying by r again, which would be r squared. So in this problem, you have 1 plus 1 times 1/2 plus 1 times 1/2 squared, etc. So this is called a geometric series. So for a geometric series, in order to figure out whether it converges, so whether this is going to get to a sum, or if it diverges, basically this has to be true. The only way that a geometric series converges is going to be if that r value, or the absolute value of that r value, is less than 1. Because that's what's going to guarantee that these numbers are going to get smaller going forward. Now, if that common ratio absolute value of r is greater or equal to 1, that means as you keep adding numbers, you're just adding, that sum is getting bigger and bigger, so there's no way that you're going to approach a sum, so we say it diverges. So let's look at a couple problems and see whether it's going to converge or diverge. So first thing we have to figure out, what is your common ratio? So first of all, the numbers have to be getting smaller, right? So let's see if we can figure out what r is. So from here to here, what number are we multiplying by every single time? You are multiplying by 2/3. Maybe easier to look at these two fractions. Notice you're multiplying the top number by 2. Notice you're multiplying the bottom number by 3. So our common ratio in this problem is 2/3. So if the absolute value of that number is less than 1, this is going to converge to some sum. Now, right now, I don't know, or I don't care what that sum is. I just want to know whether it's going to converge or not. This one, you're just multiplying by 1 every single time. So so think about it intuitively. If I just keep adding 7 infinitely, this is just going to get bigger and bigger. So there's no way this is going to approach a sum. So this diverges. Here, you're just multiplying by 2 every time. So this is not going to approach a sum. So we say this diverges. Here, notice, first of all, the signs are alternating, minus plus minus. So you know your common ratio, or your r, has to be a negative number. And what are you multiplying every single time by? You're multiplying by 1/2. Okay? Now, sometimes if it's hard to figure out what you're multiplying forwards, okay, you can go the other way and just divide the number. It's like in the first problem, 4 divided by 6 is the same as multiplying by 2/3. Okay? The other thing we're going to do is, if you figure out that a geometric series converges, we can actually find the sum of that geometric series, and the sum of that geometric series is a over 1 minus r. So this formula should look familiar from last year from pre-calc. So a is going to be just your first term, and your r is your common ratio, and you can only have a sum if your geometric series converges. So let's take a look at a couple. So notice these problems here on the bottom are written in sigma notation instead of up here, which is that expanded notation. Now, if you want to write it out in expanded notation, you can. So we can just go ahead and plug in the counter and see what we get. So notice here the counter starts at 4, so your first term would be 1/2 to the 4th, and then the next one is 1/2 to the 5th, etc. Okay? So you are multiplying by 1/2 every time, so that's my common ratio. So we know that it's going to converge. So if it converges, I do want you to find the sum now. So your sum is going to be the first term, which in this case is 1/2 to the 4th, which is the same as 1 over 16. So a over 1 minus r. And if you simplify this, this is going to be 1/8. So this infinite series here, if you add it infinitely, is going to equal 1/8. That's what this is saying. Now, let's talk about one other thing here. Notice here, I wrote it out in expanded notation, which you can do, but I actually don't need to figure out your A and your R. Your R is going to be whatever is being raised to that nth power, because that's what you're changing every single time. So just from this sigma notation, I can figure out that R is 1/2. And then your A, which is for the first term, is just what you get when you plug in that first counter. So now when we look at the second problem, I don't have to write it in expanded notation. I can pick up my R just from the way it's written. So notice the 1/2 is being raised to the nth power, so your R is 1/2. So I know it is going to converge because the absolute value of that number is less than 1. So if it converges, I can figure out the sum. So this one, n starts at 0, so if I plug in 0, my first term is 1, so A over 1 minus R. And if you simplify that, so the sum of this series, so this sigma is exactly equal to 2. Okay, this one here, same idea. Your R value is whatever is being raised to the nth power. Notice it is only the 2 on the bottom, so your R is still 1/2. Okay, that 3 is not changing, okay? If you want to write out the first couple terms to see what happens, look what happens. Your first term is 3, as I plug in 0. Then your second term is 3 over 2. Notice the 3 stays the same, right? All you're doing is multiplying by 1/2 every time. Okay, so I've got my R, so I know it converges. So that means the sum is going to be A, which is 3 over 1 minus R, and this sum is going to give me 6. Okay, I would pause the video at this point, try the next couple on your own, and then replay the video to double check your answers. Okay, the next one, notice here your R is 3/2. The whole thing is being raised to the nth power. This number is bigger than 1, so these numbers are just going to get bigger and bigger, so there is not going to be a sum. So we just say it diverges. If it diverges, there can't be a sum, so that's it. Here, your R is 2, so again, bigger absolute value is bigger than 1, so we say this diverges. Sometimes you may need to use properties of exponents to simplify things, so I would rewrite this like this. This 3 to the n plus 1 is really the same as 3 to the n times 3 to the first. So if it's written like this, now you can see that your R is 3/5, right? It is what is being raised to the nth power. So that is less than 1, so there is going to be a sum, so I do know it converges. So your sum is A. So what do I get for the first term when I plug in 0 for n? I get 3 on the top, 1 on the bottom, so it's A over 1 minus R. And simplify that, you should get 15/2. Next one, notice here your R is negative 2/3. So again, this will converge. So my sum is going to be, if I plug in 1 for n, my A is negative 2/3 all over 1 minus, so this becomes a plus, okay? And practice simplifying your fractions. Obviously on a short answer, you do not need to. So this becomes negative 2/5. This one, your R is negative 2. Absolute value is not less than or equal to 1, so it diverges. Okay, the next one. Notice you've got 2 separate terms. So we can split this up into 2 separate sigmas. So we can write it like this. So this is the same as this. If you're adding and subtracting terms, you can basically break it up into 2 separate sigmas. So I'm going to do each one separately. So this one here, your R is 1/2, so it's going to converge. This one here, your R is 2/3. So both sigmas converge, so both of them will have a sum. So the first one, your A in this one is going to be 3/2, 1 minus R. And then I'm going to subtract it from the sum of the second one, and your A in this problem is going to be 2/3 all over 1 minus 2/3. And if you do all the arithmetic here, you can double check. I believe this is going to be 3 here, oops, and then minus 2, which gives me 1. The last 2 problems, notice it is written in expanded notation, but we can still do the same thing. R in this problem is, what are we multiplying by every single time? Notice it's 3/4. If you're not sure what it's multiplying by, just go backwards. If I divide, 6 divided by 8 is the same as multiplying by 3/4. So there's your R. So I do have a sum. Your first term is 8. 1 minus 3/4 equals, this is going to give me 32. Here, your R is negative 1/2, so I will have a sum again. Your A in this problem is 4. 1 minus, or this becomes plus 1/2, and I believe this gives me 8/3.